In question number 21, this is finding the derivative of an integral. In this case, we want to use the fundamental theorem of calculus, in that the integral and the derivative will undo each other. Now you have to be careful because the end point is a function. Okay, so this is a function. So what that means is when we apply the fundamental theorem of calculus and we substitute that term in, we have to remember to apply chain rule. So what I'm going to end up with is the integral and derivative undo each other. So I'm left with the same function I started with, t squared ln of t squared plus 1. And I'm going to substitute in my endpoint of x cubed. Now because this is becomes an embedded function, when I differentiate, I have to apply chain rule. So there's my chain rule. So when I simplify this, I end up with log of x to the power 6 plus 1, 3x squared. So when I take a look at this, this is b. Oops, not b. That's going to be c. So taking a look at the answers here, this answer here involves just substituting in, but not applying the chain rule. So you have to just be very careful of that one, where we have to make sure we apply chain rule. Number 22 shows a slope field for the differential equation. One of these differential equations will fit this slope field. So we can just test coordinates in the equations and see if they match. Now there's some things we can do. So there's some hints that we can use. So if I take a look at this slope field, I'm going to see that the slope is equal to 0 for y equals 0. So what that means is I need a y equals 0 as a factor in the numerator. So in this case here, the a and b look like they won't work. In fact, if you take a closer look at a and b, when y is 0, we should end up with a vertical asymptote. This will be undefined slopes, and we don't see any vertical asymptotes in the slope field. The other hint that we can look at is when x is 0, we have slopes of 0. Okay, so that means that x must be a factor in this differential equation. So C, we can kind of rule out B and A. We can see that C and D are our main options. So what we can do is we can kind of test these coordinates into these slope field points. We know that the blue and red ones I've highlighted will work because those are going to give us 0 slopes. And if we take a look at quadrant 3, 2, 1, and 3, we can see we have negative slopes. Well, x and y are positive, both negative, so as a product they're going to be positive. And so if the slopes end up being negative, we can say that that's D. And again, we can kind of be fairly certain of that, but we can always plug in some x and y coordinates. So I'll test this with an x and y coordinate. So this looks like it's x equals 2, y equals 3. When I substitute x equals 2, y equals 3, I end up with a negative 6 slope. Well, that looks about right. If I plugged it into this one, I'd end up with x equals 2, y equals 3, and we'd end up with positive 6. Well, clearly that slope is not positive. If I do it into here, x equals 2, y equals 3, well, that looks like definitely a slope greater than negative 1, and again, this one will give us positive. So we can rule out all those other ones, and D would be the one that seems to work.